Okay, so let's talk about garbage collector now. It is very interesting to note that garbage collector in Java is actually quite similar in concept to garbage collector in a real-time scenario. Right? So let's try and correlate this here. I'll just take an example and we will discuss how garbage collection happens in a day-to-day life, real time. Right? How do you get rid of garbage from your house? So basically, you get a lot of items to your house every day, groceries and a lot of other stuff which you need to use at home, right? And at the same time, there is a lot of stuff which you just need to get rid of, right? And you need to throw away. So what is this called? This unused items is nothing but garbage for you, right? And you need to get rid of this garbage. How do you actually get rid of this garbage? What you do is you put the garbage in the garbage bags, right? And let's say that once every week the garbage van comes and picks up all the garbage from your house, right? So the garbage guy doesn't really come into your house and ask you for the garbage and take the garbage and go. So there is a place in outside your house somewhere where you place all the garbage bags, and the garbage guy simply comes and picks up the garbage from that location, that place where you put the garbage, and clears the garbage off. So in this way you get rid of all the garbage from your house every week, right? So in a similar manner, if you try to correlate this to Java, a garbage is nothing but unused object. So here we said that garbage is nothing but unused items, right? And in Java terms, garbage is nothing but unused object. So let's say, for example, that I've used some object to get some business logic or functionality, right? And later on I don't need it and I simply left it. So this is nothing but garbage for me because this object is simply lying there around in the heap which nobody is using, right? So it's of no use to anyone. So it's nothing but garbage for me and I need to get rid of that. And how do I get rid of that? Using the garbage van. And the garbage van in Java is nothing but a garbage collector. So the JVM actually implements the garbage collection, which the garbage collector is actually going to clear up all the garbage. In other words, the garbage collector is going to get rid of all the unused objects from your heap. So for that reason, heap is also called the garbage collectible heap, right? And why do we actually need to get rid of these objects from the heap? So heap is nothing but memory, right? And the more objects you put on the heap, you are taking more space on the heap, right? You are taking more space on the memory. So if you do not clear up all these unused objects, what's going to happen is you keep adding more and more objects which takes more and more space on your memory, and ultimately you are going to go out of space and you're going to get a big out of memory error, right? And even though you don't come to that point, you will get a lot of performance issues if you do not clear up all the unused memory and make space available for new objects in time, right? So that's the overall broad concept of garbage collection in Java, right? So we have seen what a garbage collector is. So garbage collection is nothing but clearing of all the unused objects from the heap, right? So we know that garbage collector is the one which clears off all these objects from the heap, but when does it do it? So when we talked about the garbage van, we said that once every week the garbage van comes and picks up the garbage at a particular time, right? But what about garbage collector? When does it come and pick up all the unused objects and frees up the space? So it actually depends on the server implementation. We don't have anything in the spec which says that it has to run at so and so time and stuff like that. But there are a lot of algorithms which the garbage collector uses. So we won't be going into the details of those algorithms here, right? uh, but the implementation is really server specific, right? So we cannot guarantee anything that it will be run every 5 minutes or every 1 hour or every day or anything like that. But can we from our program force garbage collector to be run? Can we force the garbage collector? No. But we can always make a request to the garbage collector. So when we call this method, GC method on runtime or system, so these are static methods. So when we say runtime.gc or system.gc, we are actually making a request to the garbage collector, asking it to run. So there's no way we can command the garbage collector to run. We can only make a request, and it's up to the garbage collector whether or not it wants to run or not, right? So we can just make the request and hope that the garbage collector runs as soon as possible when we make the request, right? So what is the cleanup option you have when the garbage collector is run? So basically, let's say that you have a lot of you've created some objects in your program, right? And it's time for garbage collection, and you have not yet closed all your connections or cleared up some of the things. So where can you do that? You can do that in the finalize method. So in your class you can write a finalize method where you can put all your cleanup activity, right? And before freeing garbage collecting that particular object, the garbage collector will run the finalize method on that particular object. So if there any kind of cleanup you need to do it in the finalize method. So we saw that earlier in the try catch finally, you do the cleanup in the finally, because even though there is an error or there was no exception raised, the finally block would have compulsory been called. So you can do the cleanup there. In a similar manner, just before the object is garbage collected, the finalize method will be called for sure. So this is the place where you can perform your cleanup code, right, before garbage collecting the object. Okay. Now, so we've seen that the garbage collector is responsible for clearing up all the unused objects. We also know that now we can request the garbage collector to run so that it clears up the memory. But from my programming perspective, how can I make a particular object eligible for garbage collection, right? We know that garbage collector collects all the unused objects. So how can I make my particular object unused if I want the garbage collector to be run? So there are different mechanisms through which it can take the unused objects. So the three things listed out here is: 1, reassign reference variable, set a null value; 2, and 3, islands of isolation. So let's discuss these three here. Okay. So the first thing is reassigning a reference. So let's say, for example, that there is a class A and I created an object for A. So this is my object for A, which is A1, which is nothing but A1. Okay. Now what I do is I reassign A, the reference A, which was earlier pointing to A1. So this was earlier, A was earlier pointing to A1, which is nothing but this object on the heap. Now I simply assign the A to A2, which is nothing but another object. Let's assume that this A2 object was already created earlier, right? And I simply assign this A to A2 now. So at this point of time, A was pointing to A1 earlier, but now it's pointing to A2. So what is pointing to A1? Nothing actually. So nothing on the stack is actually pointing to A1. So that means it doesn't have any active reference A1. So this object A1 is now eligible for garbage collection, right? So how do you say whether a particular object on the heap is active or not? So as long as a particular object on the heap has a reference variable in the stack, right, it is active. So as long as there is a reference in the stack for that particular heap, that object can be reached through any means, right, and it is active. If not, it may not be active, right, and it will be eligible for garbage collection. So in this case here, A1 is eligible for garbage collection, right. So this is one method through which you can make an object eligible for garbage collection, reassigning the reference to some other object. Number 2. So here what we can do is one more thing, assign that reference to null. So this is kind of similar to reassigning the reference, but we are not reassigning the reference to another object here, but we are simply reassigning that reference to null. So this is the same case again. A1 was pointing to A1 earlier, but now since I have assigned it to null, there is no active reference to A1 now. So nobody can reach A1 now, right? So this is again eligible for garbage collection. Number 3, islands of isolation. This is actually interesting. So let's say that there are 3 objects, okay, and I can reach object A from object B, I can reach object B from object C, and I can reach object C from object A. So I have kind of references between these objects, but ultimately there is no active reference to any of these 3 objects, A, B or C, in the stack, right? So in that case, even though there are references internally, it's nothing but a circular reference which lands to nowhere, right? So that's the reason this is called islands of isolation. So this is an island which is created here, but it is an isolated island. You cannot reach that island from anywhere outside the heap, right? In real terms, from the stack references. So this is one more good contender for garbage collection, right? So these are the different ways through which you can explicitly mark your objects eligible for garbage collection. Okay, so there's something brief about garbage collection, right?